Hi guys, Fraggle Rock here. In today's video, I'm going to be showing you how I do an SNES Jr LED light mod. So let's go ahead and get started. Right here are going to be the tools and supplies that I'm mostly going to be using for this mod. Now, you can go about a couple different ways of doing this, but for this video, I am going to be using a 3mm blue LED. I'm going to be using a 470 ohm resistor. Now you can go with a higher resistance to prolong the life of your LED, but the higher resistance you go, the more dim it's going to be. I like the brightness that comes out of it at 470 ohms, but you're definitely going to need some kind of resistor. Otherwise, the power source where I hook up my LED mod will blow out the LED rather quickly. So make sure you have some type of resistor. You're also going to need some kind of wire. I like to use the ribbon cable, and I'll just be stripping off two pieces of that. I'm also using some heat shrink tubing to insulate my connections with the resistor. You can also use Kapton tape, you can use electrical tape, but you will want to insulate that resistor on the board because you don't want it shorting out with anything. And then I'm also going to be using some other common tools here. I'm also using a 1/16 of an inch drill bit. This is what I'm going to be using for drilling out the hole on the SNES Jr for where the light's going to come through. And I'm also going to be using a 1/16 inch acrylic an acrylic rod. Now this is going to act as my LED light pipe. Now this is completely optional, as is this whole entire mod, but I like to have a nice clean fit and finish with this mod, so I'm going to be installing this acrylic rod to act as a light pipe, and we'll show you how that works here in a second. I'm also using a custom 3D printed friction fit bracket to house the LED. Now, the way that this works is that the LED will go inside of this housing, right? Just like this. It'll go inside this housing, and then this housing will friction fit inside the shell of the SNES Jr, allowing you to install this mod without using any glue, and it's completely reversible aside from the drilled hole that you'll be putting in. So if at a later date you want to remove this LED, you should be able to do so rather quickly. Now, it is important to know that this mod does require you to be comfortable with taking apart your SNES Jr, to be comfortable with some soldering. It doesn't require a high level of soldering, but you will be using a soldering iron, flux, and all that stuff. So make sure you have those tools readily available and that you're comfortable using it. Also, please remember, I take no responsibility if you screw something up while you're doing this. This is a mod that you're taking on at your own risk. I'm just here to offer some tips and show you how I do it. All right, let's go ahead and get started. So let's go ahead and take a look at the SNES Jr. Remember, we're going to be doing a mod that is installing a blue LED or an LED color of your choice on the top here, right where it says on. These models of SNES Juniors did not come with any kind of LED to indicate if your console was on, or if there was even power running to the console. So what we're going to do is we're going to be drilling a hole right there next to on in that little divot. We're going to drill a hole straight down in there, and we're going to install a light pipe using this acrylic rod that I showed earlier. All right, and an LED behind it. And then that way it's going to tell us if the console is on, if power is running to it, or if you accidentally left it on. Again, this mod assumes that you're comfortable taking apart these consoles and that you have the proper tools for it. All right, so as far as the LED mod is concerned, I'll bring this back up in a little bit. but we are going to be wiring our LED mod to the power switch directly. So we're going to use one of the ground posts for one end, and then we're going to, and I'll show this up close, but we're going to be using one of these posts here to supply power to the LED. Now remember, the voltage coming out of here is rather high. I think it's somewhere around 11 or 12 volts coming from this post. So it's really important that we use a resistor to bring down that current and bring down that voltage at the same time so we don't blow out our LED. So here's the top part of the shell where we're going to be modding. Now again, I said I'm going to be drilling out that little divot there, and then using my custom 3D printed bracket here, we are going to just friction fit our LED right into place, and that's where the LED is going to live. So let's go ahead and start with drilling out the hole. Remember, I'm using a 1/16 of an inch drill bit to do this. It's really important that you have steady hands, that you mask off the area if you need to. You could also remove this power button if you're afraid that you might hit it during the process. All right, so you can remove the button and just set it off to the side for now. So just be careful when you're drilling this out. You want to make sure that you stay within that little hole there. And like I said, use the masking tape if you feel like you need it. So we have a nice, cleanly drilled out hole. And this is where our light pipe is going to go. And remember, I'm using a 1/16 inch acrylic rod that will go right in there. Now the nice thing about using the acrylic rod and the 1/16 inch drill bit is that it'll have a nice tight friction fit, meaning that you won't need to use any additional glue. However, if you feel like you need to secure it or you drilled out your hole a little bit bigger than you intended, you can always put a little bit of white glue in there or some super glue to help hold it in place. When you drill, you're probably going to get a little bit of plastic curling up right there. So if you want, you can take a file or some sandpaper or something to clean that hole up a little bit, just to make sure it's as aesthetically pleasing as you want it to be. All right, so now we're going to install the light pipe. Now recall, I'm just using a 1/16 inch acrylic rod to do this job. I'm going to be coming in from the top and pushing it through. It should be just tight enough to where it will friction fit and not go anywhere. So now notice that the off divot is sort of recessed a little bit. I'm going to be pushing this through. And I'm going to make sure it goes down just a little bit below the surface, just like that off, just like the off, right? And then come around to the other side, you'll see that the acrylic rod is way too long. So let's go ahead and snip that down. There we go. So now my acrylic rod is just the right length. Push it down a little. Perfect. All right. So that's all we need to do for the shell modification. Let's go ahead and start working on the LED mod. All right, so for this mod, I'm going to be using some ribbon cable, a resistor, and an LED. Now this part does require that you have a little bit of soldering skills, so make sure that you are comfortable using a soldering iron and then some form of insulation. That could be shrink wrap, which is what I'm going to be using, shrink tubing, which is what I'm going to be using, but you can use Kapton tape or electrical tape for this purpose as well. So I'm going to start off with a length of wire here, of ribbon wire, but I'm going to just double check. But I'm just going to double check exactly how long it needs to be. So for this mod, we are going to be running the wire from the power switch, so right under the power switch, to the top of the case. All right, I want to make sure that there is a little extra wire, so I'm going to wrap it around the post. That way, so when somebody opens the shell in the future, it has enough slack to open the top part and put it down on the desk. All right, so that looks like it should be about long enough right there. So we have about, how long is this? I'd say, for those of you who need to know, it's about 7 inches worth of wire. All right, so now I'm going to strip the ends. Now I'm going to pre-tin the wire. All right, there we go. So now we're going to just separate out these conductors a little bit, trim it down, and then we're going to get ready for attaching the resistor. So it's important that you attach the resistor to the side that you're going to be using as the negative, or the ground. So go ahead and get your resistor, and we're going to put this at the end of the wire. So that way we don't have to worry about it being in line and having to solder in 2 points. We're just going to have to solder in 1. Okay. So to keep things nice and tidy, I want to make sure that by the time I'm done with this, that both my negative and positive end are going to be about the same length. So I'm going to pull back the wire, measure it out, and sort of just guesstimate where it is I'm going to be attaching this. All right, so I'm going to measure down from the top. See, it's about where my thumb is. And that's where I'm going to snip. Snip and strip. I guess I didn't need to do the tinning on this side because I had to strip it down anyways. All right, so let's go ahead and tin this wire, make it a little easier. There we go. Now comes the slightly tricky part of trying to attach the resistor to here. You can do it just straight on the mat. I like to use a little bit of blue tack to just sort of hold the resistor in place while I do this. I'm also making sure that I add enough flux onto all the areas that this makes the job, you know, just a little bit easier. All right, so now that that is in place, I'm gonna put a little solder on the tip. Okay, now that we have the resistor soldered into place, we're going to add some insulation. I prefer to use the shrink tubing because I think it does an excellent job, but if you want to use some Kapton tape or electrical tape, you can as well. But we want to make sure that this resistor is insulated so we don't accidentally short it out on any of the other circuitry. Plus, shrink tubing makes for a nice, clean, professional look. So I'm just going to clip off a little bit of shrink tubing, slide it over the top. I'm going to make sure that it is covering both the wire and the resistor, but leaving just a little bit of metal out at the tip so we can solder that onto the board later on. I'm just using some hot air at about 100 degrees Celsius to do the shrink tubing. You want to make sure that you're not using too hot of air because you don't want to melt the wire coating or cause any other damage. And the shrink tubing is meant to shrink up at a lower temperature than soldering. So your PVC coated or silicone coated wire should be okay at about 100 degrees Celsius. But of course, don't stay in just one spot. Make sure you're constantly moving the air back and forth, and you should be okay. And of course, if you have a hair dryer or a heat gun that doesn't have temperature control, just make sure that you're a little bit further away, that you're constantly moving back and forth, and that you're not keeping the heat on there in one spot for too long. I have done this with much higher temperature heat guns, and it is possible, but you also run the risk of melting the plastics around it. Okay, so now we've got our shrink tubing on the end of our negative line, and it's about the same length as the positive. So that side's good to go. Let's go ahead and take a look at the other end here. This other end is where the LED is going to attach. So let's go ahead and get that ready. Now, like I said, I'm going to be using blue LEDs for this particular mod, but if you want to use an LED of your choice, that's absolutely fine. I recommend using the 3mm LEDs because that is how I designed my little bracket here. Oops. That's how I designed my brackets, is to hold 3mm LEDs, right? 3mm. But if you want to use a different size, you're more than welcome to. It's your choice. Okay, so now I want to attach the LEDs and the component legs to the wires. So let's go ahead and do that. Again, I want to try to make sure I am using as much of the space as possible, using up as much of the space as possible. I don't want to have like just long component legs that are unprotected. So I'm going to be chopping down the component legs, soldering it on, and then adding in some shrink tubing to make sure that it's all groovy. So this is a really important step if you plan on doing this, doing it this way, is to add your shrink tubing before you attach the wires, because the shrink tubing is not made to go over the double wide wire, and it definitely won't go over the resistor at the end. So make sure you add your shrink tubing ahead of time. Right? Add that shrink tubing ahead of time. That's a little too long, so let's go ahead and clip that back. Put on one end. Now the heat from your soldering iron will start to shrink the tubing a little bit, so be careful of that. The heat from your soldering iron will start shrinking the tubing. So just be aware that might happen. Okay, so I've got my shrink tube on. I'm going to go ahead and clip back the component legs. Remember, the long leg, at least for this LED, the long leg is the positive, the short leg is the negative. So keep that in mind when you are trimming these back. I like to keep one just slightly longer than the other so I can remember which side is which. And I'm going to be using the same little method here to attach the legs. I'm just using some of this blue tack in order to keep it in place. Stuff's really handy for doing stuff like this. I've also fluxed it up, so this should go rather... Alright, there's one. Go ahead and attach the other. Alright. Both of those are attached. And there's just enough room to slide up the shrink tubing, so let's go ahead and do that. So now the shrink tubing is slid up to help protect it from any shorts. And now I'm going to go ahead and use, again, just my heat gun set to 100 degrees Celsius to close up that shrink tube. Again, if you're using a hotter air gun or a heat gun, you also run the risk of remelting the solder in there and breaking the connection between your wire and the LED. So using a lower heat is definitely the way to go. All right, there we go. So now we've got that all nice and bundled up. All right, now this next step can be a little tricky because the hole in here needs to be small enough that the LED doesn't go through, but also big enough to allow all the components to travel through. So what I usually do first is I put the resistor end in through the hole first, and then I just bring up the other end and pass that through. There we go. Now we can pull this all the way through. And now our LED rests nicely inside its little housing. All right, next step is to actually put this all back together. So let's go ahead, flip this over. I'm actually gonna put that button back in as well while we're here. Let's go ahead and put our power button back in. All right, flip this over. And again, this is just made to friction fit right inside. So I'm just gonna take this, put it in, slide it down, and voila. It's in there, nice and good, looks good, all insulated. On the other side, it looks like my light pipe pushed up a little bit, so I'll just push that back down. All right, there we go. Let's go ahead and wire this up to the main board. All right, so for this part of the mod, I'm going to be focusing on the back side of the board. I have my LED right here. I've got my positive and negative terminal ends, and we are going to just utilize this grounding pin right here and then one of the positive terminals. So make sure that this area is nice and fluxed up because the grounding pins require a little bit more heat than normal components because of course it's going to the grounding plane and that sucks a lot of the heat away. So let's go ahead and get this melted in. And you can just use the existing solder that's there. There's plenty on that grounding pin to accommodate your mod here. So there we go. We got that on just nicely. And then you might want to put a little solder on the tip for this positive end. But here we go. Nicely done. All right. So this is the really important reason why we have to insulate this resistor and this connection because we don't want this shorting across anything. All right, now I'm just going to simply wrap this back around. Let's clean this up with a little IPA. Just to remove any of that flux that's left over. Give us a nice clean surface. Now, this is another optional part, but notice that this is going to be bending back. If you want to secure this ribbon cable, if you want to secure this so it's not like pulling around or anything, you can use a little bit of Kapton tape to make sure it doesn't go anywhere. So I've got a little bit here that I'm going to use to just hold down the wire, just so it's not flopping around in the breeze. There we go. Again, that just helps keep it in place. And we're also avoiding the wire running next to that support hole. That's a piece of plastic or peg is going to be going through there, so make sure that your wire isn't going to be pinched. All right, so this is what it looks like when it is done. Let's go ahead and start putting this all back together. For the sake of this video, I'm not going to screw things down or in. I'm just simply going to dry fit everything and then show you what the finished product looks like. And then we're going to test it out. So again, this is made to just friction fit right in here. I gave myself enough slack so when I open this up, I can set the shell side by side. Let's go ahead and put this on. All right, there it is. Let's attach some power. And let's give it a test. And there we go. Now you have an LED mod installed on your SNES Jr. and it can tell you when the power is on and if you left it on. Hope you guys enjoyed this. Please let me know if you have any questions. I'll try to provide a link to my 3D printed bracket here for your LED, the LED block, and so you can do this on your own. If you have questions, please let me know. Have a great rest of your day and stay safe out there.